So here's a nice data set to play around with, the diamond data set from using R. It's the diamond prices in Singapore dollars versus diamond weight in carats. Carats is a standard measure of diamond mass. I guess I didn't know this, but 0.2 grams. You can use library R and data diamond to library using R and data diamond to get the data set. So here we can create our plot. I think all of this we covered before, except this statement right here, right? So our LM price is our outcome, carat is our predictor. We want to figure out how big is the rock, how much does it predict its price? Too much, right? So data equal diamond just says that diamond is the data set that we're grabbing the variables from. AB line, notice if you plug a linear regression to AB line, it just adds it to the plot. LWD is line width, and 2 means twice as wide as the as it would normally plot the line. There we go. This is a nice regression relationship, right? Everything falls neatly on a line. Apparently, people value diamonds mostly with respect to their mass. Okay. So I don't think there's much to add there. Okay, so here I'm just refitting it. Ideally, you should only fit it once. I keep fitting it because it's so small. It only takes a fraction of a second to fit. So here I assign the output of LM to a variable called fit that contains lots of information about the fit, keeps the original x's, and so on. Coef is a function in R that'll grab the coefficients. There's our coefficients. So we estimated an expected 3,721 Singapore dollar increase for every carat increase in the mass of the diamond. The intercept is the expected price at a 0 carat diamond, which of course doesn't make a lot of sense, right? Crazy values at the intercept because you haven't collected any data near a 0 carat diamond. So what we could do, of course, is subtract this. This I function here just means do this operation in the linear model. It means, I don't know, I guess execute the operation. So I carat minus mean carat just centers the data. So now the intercept has a little bit more meaning, and so now the intercept, if we get the fit, I assign this to fit 2, now coef of fit 2 is 500. $501 in Singapore dollars is the expected price for the average size diamond in the data, which is 0.2 carats. Okay, so now we've kind of created a meaningful intercept. So a 1 carat increase in a diamond is actually pretty big, I guess. I don't know a lot about diamonds, but it seems like, given the range of the data. So what about changing the units to 1/10 of a carat? So we can just do this by dividing the coefficient by 10. So if you look back, right, it was 3,721. So we can say we would expect a $370 change for every 1/10 of a carat increase in mass of the diamond. So that's much easier, and again, you can do that without having to refit the model. But of course, you could refit the model, right? And I just show you this right here. By now, instead of instead of putting carat in the model, I put in carat times 10. Right, and you get the coefficient, right, appropriately divided by 10. Okay, so now let's predict the price of a diamond. Let's suppose you would fit this relationship. It seemed pretty good. Now someone comes to you and says, well, I got a couple of values of carats, and I want to predict what price I should get, so I know how to haggle correctly or whatever. So they say I want the predictive values for those 3 things. Well, you could, grab the intercept and grab the slope and multiply them times the new x's, and you get your 3 predicted dollar amounts. Fortunately, R gives you a nice predict function. You say predict, fit is the what we assign the fit to, and then new data is the data that you want the predictions at. And so you want it to be in a data frame, and the variable name needs to be the same as the variable name from the regression. So so here's new x is the name of the three numbers that I wanted to get predictions at. So I'm going to rename that vector as caret in my data frame, and so now when it does predict, it knows what variable to look for to plug into, and then you can see you get the same numbers there as you do there. And so what is this doing? Let's just draw a picture. Okay, so let's take this 0.16 one. It's saying here's 0.16, oh, I need my pen. Here's 0.16, here's my fitted regression line, here's my dollar amount. Okay? Now notice that each of these red points, right, that's where we actually observe data. So the red points are the predicted ones, and the blue points are the actual observed ones. So the least squares criteria is trying to minimize the distance, the vertical distance between the blue points and the red points.